Hello guys, welcome once more to class online. My name is Mr. Dami, and in this video we shall be looking at Jamb Physics 2010 question number 21 to number 25, and we shall be dealing with those questions big time. Don't forget, if you learn something from this video, click on like button. We have a lot to share with you that will better help you understand physics. Let's get to the question number 21. A vapor is said to be saturated when what? A dynamic equilibrium exists such that more molecules return to the liquid than are leaving it. B, the vapor pressure is atmospheric. C, the temperature of the vapor varies. D, a dynamic equilibrium exists between liquid and molecules and the vapor molecules. Now, between liquid molecules and vapor molecules. Now let's see what is the answer. Now this is called when you see, like, if these two things are pots, this pot is open, is said to be unsaturated. Why? Because the vapor coming from this if this is boiling water, the vapor coming from here is escaping to the atmosphere. The vapor is escaping and running away. But if you cover the pot, then we see that the vapor in that pot is saturated, and that is one of the reasons why water boils. Boiling point is the temperature at which liquid change to what? Vapor. Okay, during saturation. That means saturation must happen before boiling can occur, and that is the reason. So now saturation occur, it can only saturate when the pot is covered, and this is what we have here. And but what is the explanation for that? There's an equilibrium between the liquid coming out and the liquid going back. Like you can see this arrow. When the water turns into vapor, it can't escape. So the molecules of the vapor move around, and some of them return back into the liquid. So it keeps coming out and going back in, and coming out and going back in. So we see that there's a dynamic equilibrium between the vapor and the liquid molecules, because the molecule of the liquid are changing into vapor, but the vapor can't escape. So it has to go back and change back into the liquid. So the vapor returns back. So the vapor and the liquid molecules are equal, because as they are changing into liquid, they are returning back into the liquid, and that is what we call saturated vapor. Is the temperature at which there's an equilibrium between the liquid and the vapor molecule, and that is the answer. So the answer is simply D. A dynamic equilibrium exists between liquid and vapor, between liquid molecules and the vapor molecule, and that's called saturated vapor. And that is what happens. Like you can see here, the liquid molecules change into vapor, and the vapor molecules change back into liquid. So they are at equilibrium, or they are equal. They are happening at the same rate, and that's what we call saturated vapor. Number 22 says the pressure of 1 mole of an ideal gas of volume 10 raised to power minus 2 meter cube at a temperature of 27 degrees Celsius is what? Now this question is talking about ideal gas, and you can see molar mass constant. Okay, molar gas constant. So this tells you that you have to use the ideal gas equation. Can you still remember the ideal gas equation? That is just this: PV equals nRT. Okay, now what is my P? Is my pressure, right? So I'm to find the pressure, right? Because the pressure of 1 mole. So the N is the number of mole. Okay, why the volume? I'm to find my P, right? So that means that this volume will go under. Okay, this volume will have to go under, and that will become pressure equals nRT over V. Now what's my N? My N is the number of mole, and that is 1. Now what's my R? My R is the molar gas constant, is the gas constant, and that's 3.8. Okay, then what's my temperature? My temperature is at 27 degrees Celsius, but it has to be in Kelvin. So I have to plus 273, because 273 is what we use to change Celsius to Kelvin, and that will become 27 plus 273 over what's my volume? 10 to the power minus 2, and that is what I have here. The 10 to the power minus 2, the 10 to the power minus 2 will have to go up, and that will give me 3.8. Okay, that's 1 times 3.8 is 3.8. Then 27 plus 273 is 300 Kelvin. Okay, now in Kelvin, the temperature is now in Kelvin, not in degrees Celsius. Then the 10 to the power minus 2 will have to go up, and that will give me times 10 to the power 2. And that will give, if you multiply this thing, you'll be getting 249,000, and that is your pressure. It now becomes 2.4 times 10 to the power 5 Newton per meter, and that is the end of the answer. 2.49 times 10 to the power 5. That will have been, there should have been a 5 there. Times 10 to the power 5 Newton per meter. Remember, everything came from the ideal gas equation. I did no magic. It's just the ideal gas equation that is talking, and that is just the equation for solving this question. And it is super simple. Next time you see that this kind of question, deal with it big time. Let's get to this, to the next question. Which of the following has no effect on radiation? Now, when the sun is shining, that is radiant energy coming from the sun. Which one cannot affect this? Which one cannot affect the radiation they are getting from on the earth? Is it density, temperature, surface, nature of the surface? Now, everything can affect radiation from the sun except density. Temperature affects radiation. That's the energy coming from the sun. It is affected by temperature, of course. The surface also affects. The surface of the sun also tells with the kind of energy that it can give, and the surface of the earth also tells the kind of energy that it can absorb. So surface affects. The nature of the surface also affects, but density does not affect radiation. So the one that does not affect is simply A, density. It does not affect how the sun shines. So that is the answer to that question. Number 24 says the wavelength of a wave traveling with a velocity of 420 meters per second is 42 meters. What is its period? Now, when you hear the word velocity of wave, one formula should come to mind, and that formula I said I have never solved a past question that doesn't have that formula. Please take note of the formula. It can help you. V equals F lambda. This formula comes out in all the past questions I have solved ever. I can't remember a year that does not bring out this formula. Please take note. Now, it is asking for period, right? Now, period is the inverse of frequency. So I'll just turn the frequency on 1 over frequency equals 1 over period. So the period is the inverse of frequency. So V equals 1 over T lambda, right? Now, what's my V? My V is speed of wave, and that speed is 420 meters per second. Okay, equal 1 over T. My T is my period. Then lambda is my wavelength. The wavelength is 42 meters, and that is 42 here. So now I'm to find the period, right? So I'll make the T the subject, which will become lambda over T. V equals lambda over T, where lambda is my wavelength. Take note, V is my wave speed or velocity, lambda is my wavelength, and T is my period. Now, I'm trying to make, because they say what is the period? So now the period must be the subject. So I'll say V equals lambda over T. Then cross multiply, T will now become lambda over V. Okay, making T the subject of formula. Therefore, what's your wavelength? Your lambda, that's 42. Then your speed is 420 meters per second. And if you divide, you'll be getting 0.1 second. And that is your period. So the answer to that question for the period is simply 0.1 second. And that is the answer for number 24. Let's check out number 25, which is the last one for this video. The sound of an electric bell dies down slowly when air is slowly pumped out from a bottle because what? Now, sound cannot pass through the bottle. B, sound can pass through a vacuum. C, sound needs a material medium. D, the wavelength of sound becomes greater in the bottle. Now, when we are talking about sound wave, under wave, we learned about sound wave, right? We were talking about electric bell. Electric bell was used for an experiment. It is called the electric bell experiment. And here it is used to show that sound travels by medium, making sound a mechanical wave. That means mechanical waves are waves that need medium for their propagation. That means sound needs to travel on something. Sound cannot travel through vacuum or emptiness. It must travel by something, and that thing is air. Sound cannot travel if there is no air. Okay, so that means that this experiment is used to demonstrate that sound needs air to travel. And what was done was that this thing was floor and there was air, so it made sound. You could hear the ringing. This is an electric bell. You could hear the sound. It was making a lot of noise. It was ringing when there was air. But then the air was pumped out. When you pump out the air and you plug it, it will ring. It will be working, but there will be no sound. So that means you can't hear a sound if there is no air in the system. And that was what this experiment demonstrated. You cannot hear a sound if the air inside this thing, inside this electric bell, is pumped out. Because sound can only be heard when there is air. Okay, so sound needs a medium to be propagated, and that medium in this experiment is just air. So that means this is done to show that sound cannot be heard without a medium, and the medium in this case is air, and that is the answer. So the answer is sound needs a material medium. So that is the hallmark of the experiment. That's all that they were trying to say. So when you pump out the air in the medium, sound can't be heard, because sound can't be heard when there is no medium. You need to have air in that system to be able to hear the sound. And that is number 25, and that is C. And that brings us to the end of this video. Don't forget, if you learn something from this video and you want to get more content, click on like button. We will love to reach you with more content that will explain so much to you. Until you speak, guys, take care of yourself and bye for now.